Welcome back, guys, to the next part of this. Remember, we said that now we're doing what is called the quotient rule. Quotient means is the result of division. So now let's move to quotient. We are dividing as we expected. Now again we will have our u and v. Now for quotient, it's very specific. You must always start by deriving u. Never in any case start by deriving v. You should always start by deriving u. That is a concept. You should follow that concept. Alright, let us start. So we have our dy over dx, which is equaling u as we are expected. So we have 2x minus 9. That's the derivative of u. Then we multiply by v. Our v is x minus 2. Then the sign is always negative in between them. Remember, when we were doing product rule, this sign was positive. That is why it didn't matter whether you started by deriving u or deriving v. But for this one, it's specific. You must follow a certain order and don't change it. We start by deriving u always, then we derive v. Now since we've derived u and find the derivative of u, now this is the value for v. Now let's derive v. Okay, we put u as u is, so u will be x squared minus 9x plus 14. The derivative of v is 1. So anything multiplied by 1 is that thing. So just multiply it by 1, then you divide by v squared. Alright, that's how you do it. You can leave it here, but today I want us to simplify this one. Now why I want us to simplify it is because I want to prove it using another method. So you'll have 2x times x, that is 2x squared. Then you have 2x times negative 2, that is negative 4x. Then negative 9 times x, that is negative 9x. Negative 9x plus negative 4x, that is negative 13x. Then we have 9 times 2, negative 9 times negative 2, that will be positive 18 minus x squared plus, okay, negative times positive is a negative. Negative times negative is a positive 9x. Negative times a positive is a negative 14. Then now we can start with these ones. 2x squared minus x squared. So we are left with x squared. Come to this one. Negative 13 plus 9. Then we are left with negative 4x. Then we have positive 18 plus negative 14. So that means we'll end up with a positive 4. By the way, this thing is this. Yeah, as you can see, we have x minus 2 all squared. That's a perfect square. And even this one, this is x squared minus 4x plus 4. That's a perfect square. And this is the perfect square, same perfect square. Let me just quickly change it so that you may see it. When we are making a perfect square, you remember on the previous example we said when we are making a perfect square, we square root the first term. So that was x squared, so now it's x. Then we take the sign of the middle term, which is negative, and then we square root the last term, which is 2. and then you just put your squared, and this thing is exactly the same as your denominator, so that means it's 1. So that means the derivative of this is 1. Okay, we went a long route to get this one. Now there is an alternative. We can just say our y is equaling the same thing, but we can just now simplify it or factorize it. Then these will cancel out, and then we'll be left with just x minus 7. And then we want the derivative of x minus 7, which is 1. So, can you see they are exactly the same? Exactly the same. So that means the quotient rule is the acceptable rule. It can be used on any problem, and it will give you the same answer you can get from any other derived method or derivation method. Okay, so let's move to the next example. Our next example will be the example I did when we were doing the product rule. If you remember, when we were doing the product rule, we had a problem of this nature. Now we will use the quotient rule to deal with this. In other words, we do not have to rewrite it, because we can now derive what is underneath the line. We have u there and we have v underneath the line. It's always like that. U is over the line, v is underneath the line. Then let us derive, and we always start by u. Just like when you're bathing. When you're bathing, you'll always start with the top part of the body before you bath the lower parts. Let's start. Let's derive this one. Okay, we can rewrite it first so that it becomes 2 ln x over x squared. Then now let's derive. So this is 2 over x times x squared minus. Remember, here we said we will have a minus. We derived u, then we multiply by v. Now we will derive v, which is 2x, and multiply by 2 ln x. Then everything over x to the power 2 all squared. Then now we need to simplify this. 2 over x times x squared. 1x will cancel out, so we'll be left with 2x, 2x minus. Then here I already have 2x times, why did I multiply them? Okay, 2 ln x, everything divided by, now if I'm rewriting this, it will be just x to the power 4. Take out x as a common factor, so I'll have x into 2 minus 4 ln x divided by x to the power 4. Therefore, dy over dx is equal to 2 minus 4 ln x, everything over x cubed. What did we get when we're using product rule for the same problem? We get exactly the same answer. Can you see? Right. Then let us move to the next example. Then we can rewrite it. Therefore y is equal to no, we don't need to rewrite it. We don't need to rewrite it this time. We'll leave it like that, because when we are doing it for the second time, that's when we will rewrite it. For now, we'll leave it like this. Then obviously this is our u, this is our v, and we are using the quotient rule. The quotient rule, we must start by deriving v. So if you want dy over dx, okay, let me write it here. Dy over dx will equal, what is the derivative of u? Minus, what is the derivative of v? This is 0, so I have minus 4 over, then this is squared, so that means this is 4x to the power 4. 4x to the power 4. Yeah, so they'll cancel out, and then I'll be left. This is negative 4x, that was 4x. So this is negative 4x, yes. I almost made a mistake here. So that means 4 and 4 will cancel out, 1x and 1x will cancel out, then we'll be left with negative 1 over x cubed. Then there is another way of doing the same problem. We can just rewrite it as y is equal to, obviously we had 1 over the, in other words we can take x above the line. Can you see now that we know the quotient rule? We do not need to say you can't derive when our variable is below the line. Now we no longer need that thing. We can derive it anyhow. So remember when we didn't know about quotient rule, we wanted to take everything of x above the line before we can start deriving. So we can rewrite it that way here. So we'll have our x above the line, then we can start to derive. Let me skip the line. Dy over dx. Now if I derive here, I'll get negative 2x, negative 2 minus 1 over 2. Negative 2 and 2 will cancel out. Therefore, I'll be left with negative x to the power minus 3. That goes below the line, and I'll end up having negative 1 over x cubed. Exactly the same answer I got here. So it doesn't matter which derivation method you are using, the answer will be the same. That means you are correct. If you don't get the same answer, you did something that you were not supposed to do. Let's go to the fourth example. I really like this one. It's very interesting. So let us derive. Obviously, this will be our u and this will be our v, and there is no need for us to rewrite anything. We just go straight to our derivation. So let's derive. We will have 10x ln 10 times ln x. The derivative of u, let me put brackets, but I'll use a pencil so that you can see where it goes. This is the derivative of u, that means this is u prime, this is v. Now I'll derive v. The derivative of v is 1 over x times 10 raised by x. Now again, I'll put in bracket, this is v prime, whereas this is just u, because this time we didn't derive u. Everything should be divided by ln x whole squared. This is ln. Then at this side you just have your everything divided by ln squared x. So this will be your answer. Again, this will be our u, this will be our v. we always start by deriving the numerator, which is u. So we'll have dr over d theta. So our u, when I derive it, I'll change the sign. Remember when we did a similar problem on product rule, I said that since I will change the sign, I'll rather take it to the other side, but this time I can't start by deriving sign. I have to start by cos, because that's my u. I always start with u, then we multiply by, we say negative. Then this time we derive this and multiply by that one. So we'll start by that, cos theta, then let's derive this one. When we derive this, I'll get 0. Then if I derive this, I'll get negative. There's no sign change, so it will stay as negative. Then I divide everything by this one, 1 minus sine theta, all squared. I can leave it here, or I can go one step further. I multiply out by those, so I'll have minus sine theta times 1 to be minus sine theta plus sine squared theta minus, then here it will be 0, it will be positive, cos squared theta. Okay, divided by this 1 minus sine theta all squared. Now if I want to continue, you can see this is 1, so that means I'll have 1 minus sine theta as like this. So in other words, I can have 1 minus sine theta, and it will cancel this one, and then we'll be left only with 1 of this 1 minus sine theta. So the answer could be, if I wanted to continue, the answer could be 1 over 1 minus sine theta. Yeah, but it's fine, we can leave it anyway. Okay, so this is the answer that we have for the quotient rule. Now we will move, because now as you can see in this formula sheet, we did everything except the chain rule. So now we'll do the chain rule according to that formula sheet, and then we know we are done.